email to you, John, or Bob, or both, with some requests for help on coax and connectors for the antenna. So just if you can.
Yeah, I'm glad to help with that.
I see there's different varieties. That's all. I'll ask you, which one specifically.
Yeah, it's kind of confusing when you're getting started, and they're inexpensive. I have a pile of different antenna connectors and so on, which I'm happy to provide new hams.
Yeah, well, we used to do 50 ohm coax in our computer department back in the 80s. So going back to coax is going to be interesting.
Okay, well, I hope you've still got some.
That sounds like early Ethernet.
Yeah, that too.
Yep, that's what it was, pre-twisted pair and then pre-RJ45. Yep, that's true.
Okay, it's 7 o'clock. That means we can start. Welcome to our 6th and final class after tonight. All of you will be fully equipped to pass your technician class exam, and we will be encouraging you to go out and take that test quick before you forget all the good stuff we've taught you. As before, please mute your mic until you have a question. And if you can put your first name and your screen name, that'll help us take roll. We're following along in the exam questions in the order presented in Gordon West's book. And just a reminder, here's the email addresses of all us primary instructors, and we are very happy to answer questions from any of you about ham radio at any time. This is being recorded, and you can find the recordings if you do a search on XCZCOMM. That's our YouTube channel. Class 6, you guys are well equipped. Tonight, I'm going to repeat offer I made about programming your new radio equipment. Karen's our main instructor tonight. She'll talk about the exam questions about antennas. Then I'll talk for a little bit about local radio clubs and make some recommendations. Karen will resume with exam questions about coax cable. Roxy will join us. She's learning CW, and she'll share her experience with you on that. Karen will resume talking about safety issues. And then Ben will talk to us about his experience with online testing, as will Mike from this class, who just passed his online test last week. And we'll have a Q&A about getting licensed and the way to do that, and answer any questions that any of you have. So this is just to repeat what I said last week. When you get your new radio, if you get one of the ones we recommended, or possibly even if you don't, we'll be glad to program it for you. You can do it yourself. There's information on the screen about doing it, but as a new ham, special offer from us, your generous instructors, we'll be glad to load the 127 useful local frequencies into your new radio. Just email one of us and we'll figure out how to get together with you, and be very glad to set you up so that your radio is working for you. And if everyone could mute their mic, please, until you have a question, that would be great. Speaking of questions, you can ask us at any time. And does anyone have any questions now? Just figuring out who's got an open mic and closing it. Anyone have any questions at this point? Karen, please go ahead.
Sounds good. Welcome everybody to this, our sixth and not quite final class, but the final one that's covering the material for the exam. Thank you for sticking with us this long to get to my class. I appreciate it. I'm just gonna really quick, before I show my slides, show this cheat sheet that I made for the antenna section of the exam questions. It includes a lot of information that's not on the exam as well. And John will be emailing this out to you guys tomorrow. So don't worry about trying to capture all this information that's in this eye chart that I'm showing right now. And with that, are there any specific questions that anyone has before I dive into it? Don't be shy, I like questions. Okay, as always, feel free to unmute and ask questions at any time, or feel free to ask questions in the chat. And my wonderful co-instructors will be monitoring the chat on my behalf and will get your questions answered as quickly as possible. Okay, so we're gonna start the antenna section with some definitions. And of course, I can't see the edge of my screen. And my mouse has disappeared, sorry. Okay, anyways, I'm just gonna not worry about the edge I can't see. So the interface, an antenna is an interface between radio waves that propagate through space and electric currents that are moving in metal conductors. So this is really where the magic happens. We take electricity that's moving and we turn it into magical waves that don't need anything to conduct. It's really awesome. And the reverse is also true. They take radio waves and turn it back into electricity so that we can hear it through our radios. Feed line is just nothing special. It's just the wire, the piece of wire that connects your transceiver or your radio to your antenna. Polarization, specifically when talking about antennas, refers to the plane in which the electric field of the antenna is oriented. That's not on the exam, so don't worry about memorizing that it's the electric field, but I thought you might want to know. Gain is the increase in signal strength in a specified direction compared to a reference antenna. This is a really dense definition, sorry. Which is generally a hypothetical isotropic antenna. Basically what we mean is that in theory, in a theoretical isotropic antenna, energy is radiated equally in all directions. Gain is the amount of extra energy in a specific direction. So when we shape that field, because we don't have a theoretical antenna, we have a real antenna. It doesn't look like that, it looks different. So, and then we look at a specific direction, gain is the amount of energy more than the theoretical that we radiate in that direction. And usually, or the amount less. And usually like a dipole has, I think it's 2.2 dBs over isotropic in its maximum direction. When we talk about the gain of an antenna, we usually talk about it in the direction in which the gain is the maximum. Does that make sense to anyone? Seeing at least one nod, so that's a good sign. And this is just a picture that illustrates that. In the bottom left picture, that's a radiation pattern actually for a dipole antenna, and that shows how it radiates in multiple directions fairly equally. And on the right, we see something that's more like a Yagi antenna. don't worry about that. We're going to be talking about that more in a little bit more detail, but it shows that it shapes the energy and points it in out the one direction. So next we're going to talk about a bunch of different types of antennas. And I'm going to be going over some information that's not on the exam. So just try to pick up what makes sense and then worry about the exam questions. Would it be helpful if I specifically mentioned which parts were on the exam and which parts weren't as I go through the material?
I think that's always helpful.
Okay, then let's do that. So dipoles are usually, but not always, made out of wire. So we usually refer to them as wire antennas. Generally, with our dipoles, and this is on the exam, the overall wavelength of a dipole is usually a half wave, or the overall length of a dipole is usually equal to half a wavelength of the frequency on which it's resonant. So if my dipole, if I'm cutting a dipole for the 2 meter band, it's generally going to be about half a wavelength long or about 1 meter long from end to end. A traditional dipole is fed in the center. That means your feed line connects in the center. So each side is going to be a quarter wavelength as indicated on the schematic on the upper left. The radiation pattern is indicated by the diagram in the bottom right. The dipole would be running, I really wish I had my mouse for this, through the middle of the figure 8, sort of horizontal on this picture, with sort of one circle coming out of the one side of the dipole and the other circle coming out of the other side of the dipole. So the radiation pattern is on the exam. Most of the radiation, the important part for the exam is that most of the radiation is broadside to the antenna. And then another thing about these that's on the exam is that they are generally mounted horizontally, which gives them horizontal polarization. And these are great antennas. They're really easy to make yourself very cheaply. And they are some of the most common HF antennas. Overall, just a rugged workhorse antenna. So Yagis are sort of I think of them a little bit as a cousin to a dipole. They consist of a driven element, which is the element that's electrically connected. So that's the element that's connected to the feed line. And that driven element looks a lot like a dipole. It's got 2 halves, it's generally fed in the center. But it's often made out of more rigid metal rather than wire. You can make it out of coat hangers or metal rulers if you're interested in home bringing them. So you have this driven element that's electrically connected, and then you have elements that are interfering with the radiation pattern, but they're not directly electrically connected. You have elements called reflectors, which are longer than the driven element and push the RF energy away from them. So the RF energy that's coming towards them sort of bounces off and goes back towards the driven element. And you have elements called directors, which are about 5% shorter than a driven element. And for those, they help focus the RF energy coming towards them. So the maximum radiation goes in the direction that the directors are, as indicated on the diagram. So Yagis are considered beam or directional antennas, and that is on the exam. Um, like all beam antennas, they concentrate gain in one direction, or they concentrate the RF in one direction. The polarization for these is in line with the driven element, and that they're also generally mounted so that the polarization is horizontal, and that is on the exam. And the radiation pattern looks a lot like what's shown in the bottom right diagram. One of the cool things that you can do with Yagis, and Lisa does a little bit of this, is radio direction finding. Lisa uses radio direction finding with Yagi antennas to hunt for whales who have transmitters on them, as part of her work helping entrap whales. But you can also use them in a radio sport called fox hunting, where people hide transmitters around and you go searching for them. It's sort of a combination of orienteering and radio that looks like it could be a ton of fun. Radio direction finding for Yagis is on the exam. So next up is the quad antenna. This is another type of beam or directional antenna, which is on the exam. So it also concentrates signals in one direction. These are generally made of wire, and it's similar to a Yagi in that you have directors and reflectors and a driven element that's the electrically connected element. But in this case, they're made generally, not always, the shape can change, of a square. So each element is a square of electrically conductive material. Usually they're a quarter wavelength on a side. They're often mounted point down, so that they look like more of a diamond shape than a square shape. And the only thing you need to know about these for the exam, by the way, is that they're a beam antenna that concentrates signals in one direction. The radiation pattern looks like that. It looks very similar to that of a simple dipole, but the figure 8 is more elongated and narrower. So they have radiation coming out of the front and out of the back. These are horizontally polarized if fed at the top or the bottom, and they're vertically polarized if they're fed at either side point, which makes it really easy to switch your polarization for these antennas. They're used for HFDX, which is long distance. Generally, DX means anything outside of the US for us in the US, or weak signal work. Dish antenna, we're all familiar with dish antennas from TV, satellite TV. And the thing to know about these for the exam, the only thing that's on the exam is that these are also beam antennas that concentrate signals in one direction. They're honestly not commonly used for amateur radio. So I can't tell you what they're used for. Their most common use is for satellite TV. They consist of a parabolic shaped reflector with a small feed antenna at the reflector's focus. So the part that's sticking out in front of the dish is actually the antenna, and the dish itself is the reflector. They have a beam pattern that's fairly narrow and pencil shaped, but it still looks a little bit like that of a Yagi, in that it has those couple of side lobes. The polarization of the antenna is the same as the polarization of the feed antenna, so it can be either horizontal or vertical. So next we're going to talk about 1/4 and 5/8 wavelength vertical antennas. And I know this picture has a half wavelength antenna on it as well. But we're gonna ignore the fact that that's sitting in the middle of the diagram. So the concept is very simple. These are vertically mounted antennas that consist of a wire going up, just like the antenna on your HT. This is just a simple vertical antenna sticking straight up. But they're in 2 different sizes. One's a 1/4 wavelength long and the other's a 5/8 wavelength long. They're both monopole antennas. They're generally mounted vertically. You don't really see monopole horizontal antennas. The radiation patterns, I'm going to pull up another slide. And this is a cut across look at the radiation patterns. So these radiation patterns are actually omnidirectional, but they have lobes that go up. So they radiate not like flat, but up. The in green is the 5/8 wavelength, and in blue is the 1/4 wavelength antenna radiation patterns. So as you can see, the 5/8 has a lower radiation pattern and higher gain than the 1/4 wavelength, and that is on the exam. These are vertically polarized antennas, and they're often used for mobile and base station VHF, UHF antennas. And this last antenna is not on the exam at all. But I'm mentioning it because it's one of the antennas that we recommend people consider purchasing. So I thought it'd be fun to also talk a little bit about the J-pole antenna. So the J-pole antenna consists of a half wavelength radiating section with a 1/4 wavelength long matching stub. So this 1/4 wavelength long part at the bottom that's doubled over doesn't radiate at all. All the radiation comes out of the higher up half wavelength section. These are generally also mounted vertically, and they're very cheap for their performance. They have higher gain than a 1/4 wavelength monopole and a similar radiation pattern to a simple dipole. And they're generally vertically polarized, and they're often used for base station VHF and UHF. They're a nice little wire antenna. So for anybody considering Aries, you can get a roll-up version of a J-pole, which is just a piece of wire basically that you can easily roll up and take in your Go kit to set up on the fly. So next I have a couple of selected exam questions on the antenna section of the test questions. Mostly the ones that have math in them. Everybody's favorite, right? So what is the approximate length in inches of a half wavelength 6-meter dipole antenna? Now the book has a way of going through these questions, and if that works for you, great. Wonderful, use it. If that doesn't work for you, I have what I think is a simpler way of answering these questions that I'd like to introduce. So we know that the wavelength is approximately 6 meters because the test question tells us that this is for the 6-meter band. So the antenna length is going to be a half wavelength long because this is a half wavelength dipole antenna we're talking about, which means the antenna length is going to be about 3 meters. We don't need to be very precise to get the right answer on this question. So we're going to say that that's approximately 3 yards. And that makes it about 9 feet long. 9 feet times 12 gives us 108 inches, which is approximately the right answer. So we're going to select the closest answer to 108 inches, which is 112 inches, which is the right answer. Any questions on this? Does this make sense?
Thank you for clarifying that question. I wondered where,
I'm sorry, your audio cut out.
thank you for clarifying that question. I wondered for quite a while where the 468 figure came from in the formula.
I don't like it. It comes from basically clumping together a whole bunch of conversion factors. I find it much easier to not worry about memorizing one more weird number and just approximate the answer.
Thank you, Karen.
You're welcome. So next test question I wanted to review is, how would you change a dipole antenna to make it resonate on a higher frequency? So the answer is that you need to shorten it, because a higher frequency is a shorter wavelength. So they just have an inverse relationship, but that can be a little bit confusing. So I just wanted to review that one in particular. Next, we have the other math question that talks about antenna length that I just wanted to go over. You can, again, use the way the book introduces it, or you can estimate the answer, which is good enough to get you the right answer. So in this case, we're asked, what is the approximate length in inches of a quarter wavelength vertical antenna for 146 megahertz? The main difference with this question and the previous one I went over is that you first have to find the wavelength of 146 megahertz. So hopefully we've already memorized the formula 300 over frequency for the wavelength, or we can memorize that 146 megahertz is in the 2-meter bands. Otherwise, 300 over the frequency is 300 over 146, which is about 300 over 150. So it's approximately 2 meters wavelength. The antenna length is a quarter wavelength because the question tells us it's a quarter wavelength vertical, which means that the antenna length is going to be about 0.5 meter, which is approximately 1/2 yard, which is approximately 1.5 feet. 1.5 feet times 12 to convert to inches gives us 18 inches. And as before, we select the closest answer, which is 19 inches, which is the correct answer. Any questions? I know my question slide isn't as pretty as John's, but hopefully nobody will hold that against me. And John, are you able to stop my share? I really did lose my mouse.
Probably.
That would be appreciated.
Looks like I can.
Oh, and I found my mouse again. Yay. So are there any, does anybody have any questions on this section? Any of the questions in this section or anything I went over?
Unfortunately, I had a phone call coming when you were explaining the half dipole, the 6 meter dipole, and you got into the wave that you were using the half wavelength, which was equal to 3 meters, and I sort of lost from there. And I was just wondering if you could back up a couple slides, or is it too late? So
It is not too late. Let me share my screen again.
Sorry.
Not a problem. I'm not going to go full screen so I don't lose my mouse again. So what is the approximate length in inches of a half wavelength 6 meter dipole antenna? So the question tells us the wavelength is 6 meters. And the question tells us that the antenna length is a half wavelength, which is about 3 meters. For the purposes of this question, we don't need an exact answer. Estimating it is going to be good enough. So we can call that 3 meters to be approximately 3 yards, which is approximately 9 feet. 9 feet times 12 is 108 inches. And from there, we just pick the answer that's closest to what we got. And that gives us 112 is the closest, and 112 is the right answer.
Thank you so much. I worked on that the other night, and it was a longer process the way I was doing it. So thanks for the shortcut there for the yards to meters. I didn't even think about it.
You're welcome. Any other questions on this content? Okay, well, with that, John is going to give us a little discussion about some local clubs.
Thank you, Karen. You know, some people think radios are magic, and they're not exactly right. They're close to right. There is magic here. The magic isn't really in the technology. The magic is in the people, and the people you can talk to, and the things you can do by working with people over the radio. And so it's useful to connect with other local hams. And one way to do that is through local radio clubs. So I'll tell you about a few. The Santa Cruz County Amateur Radio Club has been around since 1916. That's even longer than I have been around, and still going strong. The details about it are at its website. K6BJ was the call sign of one of the founders, and the club still uses that call sign for its repeater and for its website. So if you can remember that, you can find the website easily. Or if you just Google Santa Cruz County Amateur Radio Club, you'll get there as well. Their next meeting is this Friday at 7:30 p.m., where they have an interesting program. And I can't put the Zoom link on this recording, but I'm glad to give any of you who email me a Zoom link for the meeting of this Santa Cruz County Amateur Radio Club. And they welcome new hams, guests. You'd be most welcome if you wanted to attend and check in. So send me a short email and I will give you the Zoom link. Another great local radio club is the San Lorenzo Valley Amateur Radio Club, which goes by this abbreviation, San Lorenzo Valley Amateur Radio Club.org. They meet the first Friday of the month, as opposed to the Santa Cruz County Club meets the the third Friday. They're a great organization. Their membership tends to be a little more technical. That's just the way it's worked out. And so their meetings often have more technical topics. You can join one or the other or both of these, or you could just show up and see if they're interesting. If you're up near Loma Prieta, there's a smaller but very focused group of hams who are in the Loma Prieta Amateur Radio Club. And you can find them by Googling that name. This is their website. They meet the first Thursday of the month. all of you, when you get your license, I recommend that you join the ARRL. That's the American Radio Relay League. It is the one national organization that supports and advocates for amateur radio. They're connected to the FCC. They give opinions to the FCC about pending rule changes. And they publish a great magazine for new hams called On the Air. It's a magazine specifically for people who are new to the hobby. And it'll be a very useful tool for you as you're getting started. They publish several other magazines, which are also accessible to you if you join this organization. And lastly, the Amateur Radio Emergency Service is a group of us hams who are interested in public service and emergency preparedness. And there is a very active number of us here in Santa Cruz County. In fact, we're so active that we put this class on because we want more people who would be interested in joining the fun. In addition, as a way to prepare for emergencies, we provide communication services for local events such as the Santa Cruz Triathlon or other big sporting events where there's a need to coordinate over a large area. And that turns out to be great practice for things that we might be called upon to do in a communications emergency. This is the website for the Santa Cruz Amateur Radio Emergency Service. This looks kind of funny. XCZ is actually the county government abbreviation for the county. All the counties in California get a 3-letter abbreviation, and ours is XCZ. If you're interested in learning more about this, you can email me. I'm one of the emergency coordinators. Actually, all of your instructors are tied into Amateur Radio Emergency Service, and we would invite all of you to join us after you're licensed. Any questions about local clubs or something similar? It's back to you, Karen.
Thank you, John, for that lovely overview of our local clubs. I am going to share my screen again. Okay, next we're going to talk about coax. And I've once again lost my mouse. So you'll have to rescue me at the end of this, John. So coax is an abbreviation for coaxial. And coax is a type of 2-conductor cable where one conductor is a central wire and the other conductor is a shield around the first conductor. So it's called coax or coaxial because the 2 conductors share an axis, which is the axis going through the center of the center conductor. The 2 conductors are separated by some sort of non-conductive material, usually a dielectric, but sometimes it can be air as the primary non-conductive material that separates the 2 conductors. Currently, coax is the most common type of amateur radio feed line, but that wasn't always the case. And it's so common because it's very easy to use and requires few special installation considerations. And that exact phrase is on the test. And one of the major themes of this section, if you've gone through the questions, is that coax is vulnerable to moisture contamination. Everything that destroys coax seems to be moisture. We worry about UV with coax because it can break down the jacket and cause moisture contamination. We worry about how well our connectors are sealed because moisture can contaminate it. If you have a question on the test that's talking about some sort of failure with coax, the answer is going to be moisture contamination. And the reason we worry about moisture contamination with coax is because it results in higher transmission losses. So the next definition is impedance. So impedance is the effective resistance to alternating current, which is a combination of resistance and reactance. Most amateur radio transceivers expect the antenna system to have 50 ohms of impedance. And for that reason, hams mostly use coax with 50 ohms of impedance. Coax is also used for your cable TV system. And for cable TV, it's usually 75 ohms impedance cable. So don't just use a spare cable that's lying around for your amateur radio system, unless you're sure that it's got the right impedance, or you understand that the impedance is different and it's going to result in things not maybe working quite the way you want it to. Which brings us to SWR, which is the reason that having the wrong impedance coax can be a bad thing. SWR stands for standing wave ratio, which is a measure of how, in general, standing wave ratio is a measure of how well a load is matched to a transition line. And this has to do with how well the impedance of a load is matched to the impedance for the transmission line. If there's a change in impedance, some portion of the power is reflected back, resulting in losses. This is similar, if you're familiar with optics, to how if you have a change. Was there a question? Okay, so this is similar to optics. If you have a change in index of refraction, you're going to have some amount of your light reflected back. If that's not making any sense to you, don't worry about it. It's not at all relevant to the exam. But if there's a change in impedance, some portion of the power is reflected back, and that results in losses. Not all of your power is then going. So if you have your radio, your transceiver at 50 ohms, your cable, your coax feed line going to the antennas at 50 ohms, and then your antennas at 100 ohms, when your signal gets from the feed line into the antenna, some portion of the power isn't going to make it into the antenna. And instead of being radiated out so that you can talk to people, it's going to bounce back into your radio. So that's bad for a couple of reasons. One, it reduces how much power you're transmitting and effectively getting out with. And two, the reflected power comes back into your transceiver and can damage your output amplifier transistors. And then any power that's lost in the feed line is converted to heat. Those two items are on the exam. Also on the exam is the fact that when we talked about standing wave ratio, we do measure it as a ratio. 1-to-1 is a perfect impedance match. So if I have my 50 ohm transceiver or if I have a 50 ohm antenna and a 50 ohm feed line, that's 1-to-1 perfect match impedance. Anything over 3-to-1 is considered an impedance mismatch. So something like 4-to-1, which is on the exam, would be considered an impedance mismatch. So some more things to know about coax. In general, what happens is the frequency of a signal passing through coax cable is increased. And the higher we go in frequency, the greater the loss. So is going to be of energy within the coax. So what this means from a perspective of putting together your system is that when we're at lower frequencies, what coax we use doesn't matter as much. We can spend less money on our coax because the loss isn't as great. But when we get to higher frequencies, like VHF and UHF and past 70 centimeters into like microwave, the losses get really big, and we want to spend, it's worthwhile to spend more money on our coax to alleviate that loss. Okay, next we're going to be talking some about different types of coax connectors. As I recall, the exam mostly talks about two major types of coax connector. And the first one here that it's talking about, it says PL259, but what I'm going to tell you, you can refer to as PL259, and that's the male connector. The female connector is, I believe, SO239. Is that correct, John?
Yes, after I find my unmute button, SO239 is the female connector.
SO239 is the female. Combined, when you're talking about these two connectors in general, we call them UHF connectors. So which of the following is true of PL259 type coax connectors? They're commonly used on HF frequencies. And the reason that they're commonly used at HF frequencies is because their loss isn't too bad and they're cheap. They're just cheap. And they're pretty good for the cost. They're also common on 2 meter and 70 centimeter radios. Anything past 70 centimeters is no longer going to be using PL259 type connectors and UHF type connectors. So which of the following connectors is most suitable for frequencies above 400 megahertz? Which, yes, technically includes 70 centimeters for anybody paying close attention. So this is going to be an N-type connector. So an N-type connector is less lossy, but more expensive than a UHF connector. When you get into really high-end VHF, UHF, or particularly UHF applications, they all use type N connectors instead of UHF connectors. But you're unlikely to see it on your first mobile transceiver, for example. So next we're going to talk about different types of coax cable. And this question talks about RG58 and RG8 coax cable. So RG58 happens to be a very thin cable. RG8 is a much thicker cable, so RG8 has less loss at any given frequency than RG58. In general, the thinner your coax, the more lossy it is. That's a generality. I believe there are some exceptions, but I am not. I can't come up with any. But in general, the thinner your coax, the more lossy it's going to be. And this is a picture that shows some different types of coax. As a comparison, you can see the RG58 is thinner than the RG8X and the RG8U. Which of the following types of feed line has the lowest loss at VHF and UHF frequencies? So one of the ways to look at this question is, first of all, the amount of impedance doesn't have anything to do with how lossy the cable is unless you have an SWR issue. But inherently, the cable itself doesn't have any difference in loss. So you can eliminate A and B right off the bat. We're not really talking about unbalanced cable. So you can eliminate that one, which leaves air insulated hard line, or you can just memorize that air insulated hard line is going to be the best. This stuff is very expensive and it's very fragile. It has to be handled a little bit specially. And it's air makes a better insulator, but it's very vulnerable to moisture contamination. And it has these little plastic standoffs that help keep the center conductor in the middle of the shield to help keep them aligned. So next is really just a definition question. What instrument is used to determine if an antenna is resonant at the desired operating frequency? And believe it or not, an antenna analyzer is the right answer. It is the simple, obvious question or obvious answer to this one. Antenna analyzers are great. They're a little pricey, but they're wonderful. They look just like this you're seeing on your screen, and they graph the SWR at different frequencies. So they analyze a range of frequencies for SWR is one of the things that they do. They do a few other things as well. And they're great tools. Next, we're talking about the proper location for an external SWR meter. So if we're going to measure SWR, where do we want to measure it? So remember, SWR has to do with the impedance on the feed line between the transmitter and the antenna. So that's where we want to measure our SWR, in series with the feed line between the transmitter and the antenna. What can cause erratic changes in SWR readings? And I had to leave this question in the slide deck just for John. So if you're having erratic changes in your SWR readings, it's likely that you have a loose connection up at the antenna or a loose coax cable feed line connector. Ask me how I know. To diverge for a second.
How do you know that, Karen?
Oh, thank you for asking me, John. So John was kind enough to give me or provide me with a length of coax that I used for my first HF antenna shortly after I got licensed. And I got on the air and people were telling me that I didn't sound very good. And I thought maybe my radio, because I bought a used radio, was broken and there was a problem with that. So we started taking the radio apart to see if maybe there was a capacitor that was having an issue or something like that. And then someone comes over, hooks up an SWR meter and goes, your SWR is bouncing around. You have a loose connector. So it can be the obvious problem when you're having station issues. And if you're having erratic changes in your SWR readings, check for loose connectors. So what instrument other than an SWR meter could you use to determine if a feed line and antenna are properly matched? So iambic pentameter, as we all know, is something that has to do with English classes and Shakespeare. So we're not going to choose that answer. The right answer is a directional watt meter. So a directional watt meter, if you just think about that phrase, measures power. So a directional watt meter measures power traveling in a specific direction. So what we can do is we can look at power going out the feed line and power coming back in the feed line, and see if we have any power being reflected and coming back down our feed line. So that's why a directional watt meter can also be used to determine if your feed line and antenna are properly matched. So next we're going to talk about antenna tuners. So what is an antenna tuner? This is basically a definition question. And an antenna tuner is a device that matches the antenna system impedance to the transceiver's output impedance. It's basically composed of some big capacitors and inductors, and helps match the system impedance so that it looks right to your transceiver. Next is another definition question, which is what is a dummy load, basically? Well, it's not quite a definition question, my apologies. So what is a dummy load? A dummy load is a piece of equipment that you, it's 50 ohms, but it doesn't radiate. So you can connect it to your radio system. It'll to prevent you from transmitting signals over the air when you're making tests of your system without frying your radio. So in order to do this, a dummy load consists of a non-inductive resistor and a heat sink. So basically, all it does is it converts the energy through that resistor into heat, and then it has a big heat sink in order to dissipate the heat as quickly as possible. And that brings us to the end of this section. Are there any questions on this section? Okay. Thank you, everyone, for sitting through my next section. And next up, we're going to have Roxy talking to us about CW and the Long Island CW Club.
Hello. So I am going to go through just my experience. It is not comprehensive about CW. It's not a history of CW. It's just that I thought it was cool and I jumped into it. I'm going to share screen if that's okay.
Sure, go ahead.
Okay. Acrobat. Share. Okay. My screen is called CW Excitement because it's very exciting. So I have my general, and you know, I spent so much time studying for my tech exam as well as my general, and I was like, you know what? I kind of don't want to study anymore. I don't want to go for that extra and study. But I did want to take the time to try something new. I really like languages, and I thought that it would be really fun to learn Morse code. It is a great way to transmit and receive using weak signal propagation. So this is perfect if you want to be remote, if you want to climb a mountain and try to get someone on the air. You don't have to actually talk. You can just do Morse code over the air. And you can do this as low as like 5 watts, which is really cool to me, saving on power and energy. So I joined the Long Island CW Club because I started thinking more seriously about Morse code. I picked up a couple of apps on my iPhone, and I was starting to play with them. And it was, I think in November, October of last year, I don't remember when the tech class was, but Gary Watson, who is an instructor in the tech class, had pitched a really amazing story about CW and how fun it was and how he learned how to even hear the code like just out of the blue one day after he'd been trying for a really long time. So I was really intrigued by it. And so I joined the club because I thought I needed some kind of more discipline. And so one of my instructors, this is his personal practice mantra. He says that anyone can learn Morse code. You don't have to be musically inclined. You don't have to be a whiz with languages or anything. It's essentially English. But these are the 4 things that you can get taught. 1, you have to know how to copy code. So that's understanding how to listen and decipher the code. So the dits and das. Number 2 is you have to know how to send the code. So this would be you kind of turning around and, practicing writing, sending code. Number 3 is knowing abbreviations. Now, everyone can teach you this. This is like found online. So these are the things on the side. They're called CW Pro signs. They're essentially quick little characters that mean different things. And this is like a sort of like shorthand for words and information. And other things that you have to understand are like signal reports and Q codes and things like that. So those are the abbreviations. And the 4th one is learning protocol. Like when you get on the air, when you get to know someone or get to hear someone, what are the facets of a CW interaction? So you have, hey, I'm calling out, and someone goes, okay, I hear you, this is me, and then where you are, or what your name is, or what the temperature is, and usually that's enough. And number 5, he said, is something that you can't be taught, and that is courage. So just like talking on the air, you have to get on the air to practice CW. And so my next slide is a little bit of a deconstruction of what a Morse code interaction is. And this is all in dits and das. So this is not spelled out, this is not written out, but this is what is important about not only understanding the letters and the numbers, but understanding that a lot of things are truncated for brevity. So for example, here's an interaction and someone says rig HR is Collins. So that just means my radio here, wherever you are, is a Collins. And this is who is operating. So you would just say name is, and you would repeat your name. This is something that is typically repeated. So your call sign is typically repeated a couple times. Your name is usually repeated a couple times. And these are all done, in words per minute. So you can do something quite slow, like I'm probably at 5 words per minute right now because I'm a beginner, but there are people that can listen and decipher code, up to like 40 words per minute. And that gets really fast. If you've ever listened to code on the air, it's just flying by you. And, one of these days I'll catch it, but I'm not quite there yet. And so there's other things like CQ test, PSE, RPT, and that just means please repeat, RST. And this is your signal report. So these are just little quick tidbits about the breakdown of an actual QSO interaction. So I had first used my phone, and I had this kind of like Morse code app, and I could click on it and tap it with my finger, and it would make noises, but it was really, really hard to be consistent. So the Long Island CW Club recommends that you get either a paddle, which is a straight key or a paddle is 2 keys that I have here on the upper left. And this side and this side come together. So you use your index finger and your thumb, and you push them either in towards each other. So one is a dit and one is a da. And you can switch this if you want to do it right-handed or left-handed. I actually trained myself to use it with my left hand, so I could use my right hand for writing. And this is 3D printed by a guy named C.W. Morris US. He makes these little guys, and he also makes an oscillator. The oscillator is a good practice tool because you don't have to have a radio. I still don't have like my own radio. I'm borrowing a radio. So this is kind of a nice way to use a key if you don't have one. And what's cool, if you have a 3D printer, you can actually go to Thingiverse and print out your own CW key. You just need some, springs and some hardware and whatnot. And then you can actually go online and look up, how to build your own oscillator. It gets a little bit convoluted, but it can be pretty easy actually. So, whoa, I'm mousing. Okay, so in the CW Long Island Club, they utilize a online software that's free. It is called G4FON, and it is a Koch method CW trainer. It is essential to use because it gives you the learning tool of learning every letter in sequence of how the Koch sequencing is taught. So it's like K, L, M, and then you kind of use the first 3 letters, and then you drill through them. And once you get to 90% proficiency, you can move on. And so you get to choose your speed, your this distance between letters and spacing. And so they'll do drills like this, and you can practice on your own. But this is one of the ways that they do it. And you can put in text files. You can write your own text files, and you can put it in, and you can decode your own stuff. And it's really quite cool. And my mouse is so slow. Okay. So this screen on the right-hand side, it's called Precision CW Fist Check. This is another free software on, and I think I have it for PC, but I think you can use it on operating system for Macs. And you type in the letter that you want to practice, and you use your arrow key, just one arrow key, and you hit down for dit and longer for da. And so you can practice with the code, and you can match the green. So I hit the red, that's me going dit da dit. And the actual one is correcting myself, okay, I think I did the last one a little too long, or it's a little too short. And it actually measures my speed, word per minute, against the target speed, word per minute. And this is really good because if you mix your letters and your spacing between your letters, you spell different words. So accuracy trumps speed. And I'm learning that as I listen to CW and go through the classes. So my experience has been a couple months of CW training, and I would say that you can take your time and be accurate and don't worry about the speed. And I think I have one more slide if I could move my mouse. Okay, so this was my latest paddle because I got tired of hearing the plastic clicking, and it's called a porta paddle. And to be really honest, I actually didn't know it came in parts. I didn't know it came in a bag. So when I got it, I was like, oh, okay. All right, so the instructions are online. You get the PDF, and I was like, all right, well, I took Neil's antenna class. I know how to solder. I know how to put things together, and I'm going to figure it out. And so unfortunately, there was a couple pieces missing, but it's okay. The main thing was that it came together, but it didn't come with any plugs or instructions for soldering or how to put the speaker mic key to it. So actually, I asked Gary and John to help me with that a little bit, because I cut open another little wire from my oscillator, which was the purple one, and I sacrificed that, and I was like, I am determined to use it. So I threaded some really, really thin wire. I've got some leaded solder because the molten point is a little bit lower, so it doesn't burn through such tiny little copper, and covered that stuff with electrical wire and made my key work. So I'm very proud that it works now. And that's the end of my journey so far. I am leaving Gary's name and email up, because if you want to learn more about CW, I think he's the best one to explain this stuff to you and to get you going. Everything else is Googleable. Long Island CW Club. You can sign up for their membership, but you can drop in anytime. I kid you not, they have classes every day, like every day. And I actually started listening to their presentations on the weekends, and I've learned so much about different parts of like radio, like everything from like a nano VNA to antennas to how to put together my Yaesu radio. It's just, they're more of a club than just learning CW. And they're on the East Coast, so if you're an early bird, they're pretty good for you. CW Ops is another online training course. They're much more structured, but they offer like structured classes throughout the year. G4FON is on the training software. Morse Code Ninja, I use a lot. He's created a series of YouTube videos that are hours long, repeating the same things over and over and over. And I kid you not, it's actually quite helpful. And so you can find anything online, but my favorite apps are Morse Zap, which is a gamified version of Morse code for training. I liked Morse It. It's actually sponsored by ICOM Radio, and they actually include some training from CW Ops inside the software. It is like a $4.99 purchase or something, and then you get the whole suite. And then for copying practice, Morse Words is a really good random word generator. You can't even guess what words they'll say, but they're easy English words. So if anyone has any questions, please feel free to ask.
Yeah, I have a question.
Sure.
Is it, my dad was looking at the prices for some of the CW paddles, and they turned out to be like really expensive. Like $100 was like the average price, or at least what he was looking at. So is it better to just make your own paddle?
It depends, because you still should use an oscillator unless you have a radio. So, you're kind of like the oscillator and paddle, that was the 3D printed one. I think it was a combination of like $40 and $60. So if you can buy the oscillator and make your own paddle, go for it.
Thanks.
Yeah.
Roxy, nobody has to do CW. It's a big investment to learn it. What makes it fun?
Oh, I guess if you like decoding things and just like learning secret messages, like secret languages, I think it's just kind of a cool thing to learn. And when you're listening to like maybe 3 or 4 people on a certain band, and you can hear the different tones of their actual key, like it sounds like there's different people talking. And I think it's kind of cool to hear that, and to be able to decipher just different conversations. It's just like, and it's a little bit musical too. So, while you might have to study using like a computer, when you have people actually sending code, a lot of people have their personality in how they send it. So I feel like of all the kind of codes out there and digital. Like some things are just, here's a signal report and here's my station, get me your contact. But this is like a little bit more personal. Someone said, how many hours did it take to get the basic letters down? I honestly would say I'm still learning. I'm going through both of the classes again, and the second time around, I'm getting it. Like the first time I took the classes, it's like a few letters, and I would, slip between like an R and a K because it's like a dit da dit versus a da dit da. And now I'm like, boom, I got it. But I think I probably practice at night, maybe half an hour to an hour, depending on where I am.
Any other questions for Roxy? Thanks for sharing your experience as someone new to Morse code. That's very, very useful. I appreciate it.
Thank you.
Karen, it's your turn again.
Thank you, Roxy. Great presentation. Okay, so next section we're going to be talking about is safety. Okay, so first, electrical safety. So electricity can be dangerous in multiple different ways, but please keep in mind it is dangerous. Please be careful with it. Fuses and circuit breakers are two different types of devices that both interrupt power in case of overload. The difference between them is that fuses are sacrificial and melt, and circuit breakers trip and can be reset. Use a properly rated fuse or circuit breaker, because if you have a fuse that's too large, it could allow excessive current, causing a fire. That is on the test. Also make sure to fuse home-built equipment that's powered from 120 volts AC, because that's also on the test. Always make sure to follow local electrical codes. It is the local electrical codes that govern what the requirements are for electrical safety, not FCC regulations. These have been developed over the years based on accidents that have resulted in injury or death. So they're really designed to keep you safe. The local electrical codes includes rules for grounding an antenna or a tower. That is also on the test. So what's a good way to guard against electrical shock at your station? In fact, it's all of these. You want to use 3-wire cords and plugs for AC powered equipment, connect all AC powered station equipment to a common safety ground, and use a circuit protected by a ground fault circuit interrupter. In the United States, what is connected to the green wire in a 3-wire electrical AC plug? So there's some color coding in the electrical code of what wires do what. And green is for ground. So the green wire connects to the equipment ground. What kind of hazard might exist in a power supply when it is turned off and disconnected? Some of you may possibly remember this from old TVs and why they are so dangerous, the old tube type TVs or the CRT TVs. Because you might receive an electric shock from the charge stored in large capacitors. Large capacitors can hold an electrical charge for a very, very long period of time, even after the device has been unplugged from the mains power. So you always want to make sure to be careful around large capacitors and make sure they are discharged before you get your hands in there. Which of the following precautions should be taken when measuring high voltages with a voltmeter? You want to ensure that the voltmeter and leads are rated for use at the voltages to be measured. And next, my cat wants to tell you about battery safety. What can happen if a lead acid storage battery is charged or discarded too quickly? And that is the battery could heat up, could overheat, give off flammable gas, or explode. So please do not charge or discharge these batteries too quickly. Safety hazards involved in 12-volt storage batteries. You don't want to short the terminals because that can cause burns, fires, or an explosion. So be careful around the terminals. Next, we're going to talk about tower safety. And I know nobody probably has a tower yet, and you may not even be thinking about putting in a tower, but if you do, or if you are working around a tower, please, please be careful. Hams die every single year from tower accidents. When we get headlines about hams dying from accidents, tower accidents seem to come up the most often. So make sure to always wear a proper climbing harness if you're climbing. And if you're working around a tower or climbing, wear a hard hat and safety glasses. Never climb a tower alone. And never climb a crank up tower unless it's fully retracted and mechanical safety, I think that says, or mechanical safety locking devices have been installed. And yes, all of that's on the test as well. When you are erecting a tower, you want to be careful of electrical lines. And you want to make sure that everything you put up on a tower is far enough away from electrical lines that if the tower falls unexpectedly in the direction closest to the lines, that it can't come, that no part of it can come within 10 feet of the lines. And that's also on the test. You also want to properly ground any towers. And the way that you do that is use separate 8-foot long ground rods for each tower leg bonded to the tower and to each other. And we'll talk about grounding and bonding a little bit later. And that's also on the test. So just to talk about the minimum safe distance from a power line to allow when installing an antenna. This is a headline from a couple of years ago. Unfortunately, people do die from these things. So please take it seriously. And this is one of the many headlines we unfortunately get from tower climbing accidents. I really can't stress enough this one and the number of hams that we lose to it. We don't seem to lose any hams from, you know, oh, the ham dies operating his radio because the RF got to him. That doesn't happen. We have plenty of old hams who've been around RF for a lot of years without issue, but we have hams that die every year from tower accidents. So a couple more exam questions. What's the purpose of a safety wire through a turnbuckle used to tension guy lines? So guy lines are the lines that are attached to a tower or a mast that help support it. So if you look at like utility poles, they have these lines coming off of them at 45-degree, well, not usually 45-degree, but like 30-degree angles that help support them in one or more directions. Those are guy lines. And a turnbuckle is used on guy lines to provide tension, because if the line doesn't have any tension in it, it's not holding anything up. And the safety wire through a turnbuckle is used to prevent loosening of the guy line from vibration. And this is a picture of what it looks like. It just slides through the turnbuckle in order to prevent loosening. Gin pole is used to lift tower sections or antennas. A gin pole is really, it's a pole that you attach to a partially erected tower or a fully erected tower that extends up past the top of the tower so that you can lift things up to put like the next section of tower up. So that's what a gin pole is. So as promised, we're going to be talking about grounding and bonding. And there are a couple of reasons to do grounding and bonding. First of all, grounding is connecting something to an electrical ground. In the way we do things in the US, or in most places, it's literally electrically connecting it to ground. So we have rods that we drive into the ground, and the ground wires, and grounding something is to connect it to that rod that's connected into the ground. And bonding is connecting your equipment to each other so that the voltages all rise and fall together, so that there's no voltage difference between multiple pieces of equipment. So that's what grounding and bonding means. And there's a few reasons that we do grounding and bonding. We do these for electrical safety, for lightning protection, and to eliminate RF interference. So for electrical safety, you want to make sure to bond all external ground rods together. So if you put in new external ground rods in your house, you want to bond them to the existing ground rods. Your house already has ground rods, or at least one ground rod as part of its electrical system. So if you put in any new ground rods, bond them together so that they're all at the same ground level. And use low impedance connections for bonding. The best to use is flat strap, either braided or solid, as it has the highest surface area and is the lowest impedance. For lightning protection, I know we don't get a lot of lightning around here, but lightning up to, I believe what I've heard is 30 miles away can still cause damage to your equipment. And we do get lightning within 30 miles. And unfortunately, occasionally we do get lightning even closer. So for lightning protection of your equipment, because you want to keep the lightning from coming down and into your shack and destroying your equipment and potentially starting a fire as well. You want to ensure that ground connections are short and direct and have no sharp bends. Lightning likes to follow the direct route, and it doesn't like to change direction quickly. So if you have sharp bends, it might not follow the bend in your ground connection and might continue going straight. And lightning protectors, which are little devices you can install that to help protect from lightning, they should all be bonded together so that they're at the same voltage, and they should be connected to an external ground. They need to be connected to an external ground. And for RF interference elimination, so this is so you don't get noise in your signal, which can make it hard to hear people. You want to bond all your station equipment together, and you want to connect all your station equipment to an external ground. If you want more info on grounding and bonding, ARRL publishes a book, Grounding and Bonding for the Radio Amateur. Next, we're going to talk about RF safety. So RF causes non-ionizing radiation. And what that means is that the radiation does not have enough energy to cause genetic damage, which is a good thing. So RF exposure varies with frequency of the signal because the human body absorbs more RF energies at some frequencies than others, with the highest absorption being about 50 megahertz, which is about 6 meters. RF exposure also varies with the amount of power that we're putting out and with distance from the antenna, as well as with the radiation pattern of the antenna. So if we're standing in the direction of a Yagi that it's putting the most gain out, we're going to be getting more RF than if we stood at the backside that has lower gain. So there are RF exposure regulations that as a radio amateur, we are required to comply with according to the FCC. And in order to comply with these regulations, we can perform calculations based on the FCC OET Bulletin 65. We can calculate with computer models, or we can directly measure the field strength. And that is on the exam, that those are the 3 methods for compliance. We need to reevaluate our stations when we change equipment, so that we can ensure that we're still in compliance. Our exposure limits are based on an average exposure, not an instantaneous exposure. So a concept called duty time, which means the percentage of time that we're transmitting versus the percentage of time that we're not transmitting, matters when we calculate our exposure limits. And you want to not touch an antenna while transmitting because it can cause a very painful RF burn. So please be careful about that. Just to give you some perspective, the amount of distance at 100 watts I need to be away from a antenna that's at 10 meters is like 8 feet, 6 feet, something like that. So when you're talking about a 5 watt HT, you really don't need to be anywhere away from it. When you're talking about a 50 watt mobile radio, you don't need to be super concerned, but you do need to perform these calculations to make sure that you and everybody around you is safe. So one question I wanted to highlight. So this question asks about what's the maximum power level that an amateur radio station may use at VHF frequencies before an RF exposure evaluation is required. And you should learn the answer because this question is on the test. The answer is 50 watts of power. However, this is no longer true. The FCC recently changed this regulation, and we now are not exempt from routine RF exposure evaluation just by being under 50 watts PEP at VHF frequencies. So unfortunately, you will need to perform these calculations for your station regardless of power level. Next, a question on duty cycle. If the averaging time for exposure is 6 minutes, how much power density is permitted if the signal is present for 3 minutes and absent for 3 minutes, rather than being present for the entire 6 minutes? So let's break this question down a little bit. So we're looking at the average exposure over 6 minutes. And in the first case, the signal is present for 3 minutes and absent for 3 minutes. So half the time we have a signal and half the time we don't have a signal. And in the second case, the signal is present the entire 6 minutes. So in the first case, we have a 50% duty cycle, which means that if I had, for example, 100 watts, the average power, if my instantaneous power transmitted was 100 watts, the average power in the first case would only be 50 watts. And in the second case, if it was still transmitting 100 watts, it would be 100 watts. So if I wanted them to be the same, I could transmit in the first case at 200 watts, which after my duty cycle was taken into account would be 100 watts average. And that would be the same as transmitting at 100 watts in the second case. So I can do twice as much power density. I know this one can be slightly confusing because there's a lot of, it's slightly counterintuitive the way it's worded. So if anyone has any questions on this one. Okay, or if anybody has any questions on the entire section.
There's a question from the chat about grounding rods and lightning. And I think the confusion is between a lightning rod and a ground rod. In an amateur radio system, your antenna is going to be the highest conductor that's up in the air. And so the antenna might actually get struck by lightning. And what you can provide to account for that is a lightning arrestor, which is a device that will carry the lightning strike down to your ground rod rather than into your station. I'm not sure who asked the question, but if that's a clarification, I'm glad.
Okay. Hopefully that clarified. If not, please ask in some more detail. And thank you, John, because I did lose my mouse again.
That's okay. I have a mouse right here.
Thank you. Next up, are there more questions first? Okay, next up is going to be Ben talking about the online taking of your exam.
Well, hello, everyone. You've made it this far. You've gone to your 6th session with all these wonderful Elmers that you have been taught. And I would say, as every Elmer would tell you, as well as the instructors, you need to go ahead and commit to an exam date. Because really, you've really gotten so much personalized attention from them. And if there's any doubt that you might have in terms of passing your technician class, don't hesitate to ask all your instructions about that, because they are there for you. And even with San Benito VE, they really want you to pass. And as many hams that we can get on this community, the better. I had the opportunity to do my last test with them, and my last test was actually an extra, and I could not have felt more comfortable with them. They really, really assure you that they want you to pass. So as for a technician class, how much more can you be assured that you will be guaranteed that they will want to give you that assurance to pass? So I have had opportunities with previous VEs, but to me, San Benito was the best experience in my sense of taking a test. They don't give you a time limit, and they want you to make sure that you really do take the time to just really, really go through your test as slowly as possible, because they're there for you, just as they were for me. And I'm so grateful that all of you who have really stuck it out with all these instructors through Santa Cruz County Amateur Radio Club, you could not have been in any better hands. So thank you so much. And I really look forward to hearing you on the air. So if there's any questions you have about taking a test, feel free to ask me right now, but I can tell you right now, but you can put in your exam date and really feel like, okay, I know for me, when I took my extra with them, I really wasn't sure whether I was going to be ready. And it took about 2 days before the exam date where I really felt, okay, I think I can do this. So I know you can do this. I really know you can do this. So any questions on your part?
Yes, Ben, just because I'm a little insecure, there's an exam fee. Is that fee per attempt, or is it you get multiple chances to make your technician class?
In this case, I was actually surprised. It's per test. in my case, and it was actually $14 with Silicon Valley. I mean, not Silicon Valley, but San Benito VE. And I actually asked them, so why is it $1 less than that? Because they say they can do that. So you're really at a good time when you're going in for this test, because we don't really know when FCC is going to raise the rates. And when they do that, it means that the test is going to be whatever the amount is, which in this case, in San Benito, would be $14, and then whatever the licensing fee would be with the FCC. Yeah. John, if you can clarify that for me, I think that's what FCC is looking at.
Yeah, you're right.
the
Right
future.
now, amateur licenses are free from the FCC. And that's going to change shortly because of an act of Congress saying that these agencies have to recover their expenses. And at some point, I'm not sure of the date, there'll be a $35 charge for any application to the FCC. But you guys can all get in before that $35 happens. Now, Jeff, your question was, suppose you take the exam and flunk, which is unlikely to happen. Do you have to pay the $14 to take it a second time? And the answer is yes. On the other hand, you can take the technician test and pass it. And in that same session, at no extra charge, you can go ahead and take the test for the general license. And you haven't studied that, but hey, come on, it's multiple choice. It's free. Take that next test after you pass the technician test, and you may surprise yourself and pass both.
Absolutely. And that's a good point, John. If any of you who have actually advanced in your studying in the general, why not let San Benito know that you want to take both those tests? And I think they will certainly accommodate you in that session.
What was the scariest thing about taking the test, Ben?
For me, when I took the technician, John, it was actually with a different VE back east. And part of it was that they gave me a 15-minute time limit. And that was, I didn't know any better because I wasn't part of the Santa Cruz Amateur Radio Club at the time. So I was kind of doing this on my own. And the advantages that you all have is that you have taken this class with this club. And so you know what to expect. And you also know that San Benito will give you priority on your test date. So for me, we had a storm that was forecast, and we didn't know whether we were going to have a power outage. And I really didn't. I was a little concerned that there was going to be that, and I didn't want them to flake out. So I didn't want myself to flake out. So I actually emailed them and said, hey, there's this possibility I might have a power outage during the test. So that was actually the most stressful thing for me in terms of taking the technician class. But when I realized that there was actually some West Coast VEs, i.e. San Benito, there was really no concern of that because again, they are so assuring and very comforting. And again, they really do want you to pass this, your exam. I hope that answered your question, John.
Yeah, it certainly did. Mike Sharp, you just passed the exam. Tell us your experience.
Well, why don't I answer that same question? Can I go ahead and share?
Yes.
So this was before the exam, the pretest that you get from San Benito. This was the part that was scariest to me. It was going through all of these session requirements and what you have to do befores and what to expect in taking the exams. And it's this just giant list of all the things you need to think about. And in the end, it wound up not being a big deal at all. Just the way it was presented, it sure seems like a big deal when you first hit this screen. You know, it's just all about the testing environment and making sure you have stable connection, and you need to have a camera so that you can show the room that's around you. And, you know, it's just lots and lots and lots of detail, but none of it's particularly onerous. So, let's see, what can I say about the experience? I connected via Zoom to a very friendly woman whose name I did not get. And she just asked to look around the space that I was taking the test in. And when it was obvious I didn't have, you know, lots of notes scribbled on my forearms or hidden under the computers, I was connected to a session with, I think it was 3 or maybe 4 volunteer examiners. And they connected me with a multiple choice test that single screen. You can scroll from the first question all the way to the last and answer them in any order you want. And they turned off all their cameras so they weren't distracting me. And I just went down the screen and checked all the answers and hit grade down on the bottom, and I was done. And I think it was, you know, 8-10 minutes tops.
Were there some questions where you weren't sure?
No.
Then you were over prepared.
I was over prepared. I spent a bunch of time on Hand Test Online. I was doing both they have it set up so that they can generate either random tests for you or ones that focus on your weakness. And I'd seen some advice somewhere that said just keep running that until you hit in the 90s reliably. And I did. And yeah, it wasn't that big a deal when it came to taking the real thing. So I'm not sure what else to say. So if anybody has questions, Jeff.
Well, Mike, I think that you really made a good point there. You can actually be so lost on the instructions, but really it's not as hard as it seems. They're not as draconian as it seems on the instructions. And really, bottom line is San Benito really wants you to pass your class, your exam. So again, be relaxed. I know the advantage of having it online is that you're in your own setting and you can be more relaxed and you can just really tell yourself, I'm going to be fine. I'm going to do this. I had 6 sessions with this class and I'll do all right.
Agreed.
Yeah, Mike, we can get together tomorrow, you know? When the sun's up.
Of course.
Thanks.
So for those of you who don't know, Jeff is in the same neighborhood as I am. So we've known each other for years.
We had another person who passed recently. Nicholas, did you want to talk a little bit about your experience? Okay, any more questions about anything having to do with the testing? Or anything having to do with any of the material from the entire class? Not just tonight, but the entire 6 weeks?
Is there anyone who is unsure how to go about registering or signing up for a test? Okay, is there anyone who is thinking, no way am I going to take that test because I didn't understand some of the stuff?
No, John, I'm actually scheduled. This is Michael. I'm actually scheduled to take the exam on Thursday this week. Both the
That's
general
what I
and
like. That's what I like to hear. Thank you, Michael. Some of the stuff that we went over, is confusing when you first hear it. It's doesn't mean that you're somehow not suited to be a ham or anything. It's a lot of material all at once. And you know what? You don't have to get every question right. There's 35 questions. You only have to get 28 of them right. And it's multiple choice. That's the easiest kind of test to take. Well, I don't know, maybe there's an easier one, but pretty easy. So my strong recommendation, especially to people who are feeling like they're not ready, is sign up for a date soon, this week, next week, and just take the test. And you'll probably pass and surprise yourself. Our experience has been with past classes is that people who sort of want to wait until they're perfect, some of them do wait and they become perfect and they're over prepared. But some, the problem is you forget things, right? You've been showing up every Monday. You could be watching, I don't know, is Monday Night Football on yet? I guess not in May, but you could be doing something in Monday. And instead you've been here, you've invested 6 weeks of time and go take the test. You'll probably do better than you're thinking.
So John, when we go to sign up, do you have a calendar of dates and times, or is there a structure of 8 to 5 or 7 to 9 p.m. or is it?
You need to look at the website for the San Benito Amateur Radio Club. Let me
I just put the dates into the chat room that I got from Heatherly an hour ago.
Oh, thank you. Okay, so those are current open dates.
Yep.
That's great.
Excuse me, John. I've actually got that screen up right here. I can share it if you like.
Go ahead.
Oops, that's not the one I wanted to share.
This Zoom stuff is trickier than it looks, folks.
Yeah, well, I've got too many monitors here.
We all do.
Okay, so maybe I can't share it.
Okay, let me just put up a slide here that may be of some use. This is something that you've seen before, but that's not what I wanted. Okay. The first thing you need to do is, no matter where you're getting your test done, is to get this FCC registration number, and that you do from this FCC website. And I put this information in an email last week, but I'll send it out again. Just have to go to this rather long web address and fill out a fairly simple form, and then you get a registration number. They used to use social security numbers, and I'm glad they stopped doing that. This is a unique ID number, which you'll use for all your transactions with the FCC. So if you ever buy a television station, you'll need this number. Then go to the San Benito County Amateur Radio Association website, and they have their rules for online testing. But the way to get a reservation is to email Heatherly by sending an email to this address, testing@sbcara.org. And did you have that list, Mike, ready to put up, showing current open dates? You're muted, Mike, if you're talking to me. Okay. So we're seeing, oops.
Yeah, for some reason it doesn't want to share my second monitor now, so.
I think we were seeing the right screen, actually.
Oh, were you? Because I'm not sure.
Okay. Yeah, that shows upcoming test sessions.
All right, well, then it's just Zoom acting up on my end. It's showing my other screen as the one that's being shared.
Right. So there are there's one session that's full. That's this Wednesday, but there's openings Friday and subsequent Wednesdays and Fridays. So the way this works is you pick one of these dates and times that's convenient for you. Email Heatherly testing@sbcara.org, and she will fix you up. Who has comments or questions about this? Okay, one other related point. I asked last week who wanted to have their name shared with the rest of the community. I got responses from about half of you, and I'll send the contact information out to that group. If any of you fail to respond and realize now, this being the last session, that you will miss seeing all of us fine people in the future and would like to stay connected, send me a short email giving me permission to share your contact information, and you will be rewarded with a list of contact information from everyone else in this group who has agreed to share. Karen, do you have anything else for tonight?
No, I don't. That was it.
Okay, this is our last session. I have one final request, and that is when you do pass, which you will if you sign up and take the test. That is, your chances of passing are greatly increased if you sign up for the exam. So let me encourage that you do that. When you do pass, you'll get a call sign, and I would very much appreciate an email from you. Tell me your new call sign, so that when I hear you on the air, I will recognize that it was you who was in the class. All right, this concludes our series of classes. You'll get an email from me tomorrow with the same sign-up information that we were just talking about, plus Karen's very useful antenna summary sheet, which is good information. And I hope to be hearing from all of you as you pass your exams.
Does Bob want to plug the What's Next class before everyone runs off?
Oh, yes, please. Are you still on, Bob?
I am. By
What's,
golly, by gee, by gum.
what's happening June 7th, Bob?
On June 7th, we're going to have something that's referred to as What Do I Do Next? So something that we've done in the past and we've learned in the past is that we have a lot of new ham radio operators. They're working really, really hard on getting their license, and they're studying and everything else. And then they take their test, and then they just sit there, and it's kind of like, oh, now what do I do? So basically what we do is we have a follow-up class that's going to be on June 7th. So please let John know if you're interested in that. We might even be sending out also a survey as to what you're interested in. But generally we have a pretty good idea what everybody's interested in, and that is getting more familiar with your radio as to what buttons do what. What are some of the things that we found out as far as those buttons are concerned that can really mess you up, and what you can do to prevent that from happening. Also, as far as programming the radio is concerned, so yes, indeed, we will program your radio for you the first time, but what happens if something happens to the radio where you need to reprogram it or something like that? Instead of having to rely on us, maybe you might want to learn to do programming. It's not hard. The files are already loaded and stuff like that. And you can learn how to program your radio. We cover a little bit more on the etiquette is concerned. As you get your license and you start thinking about your station that you want to put in, either your mobile station or your base station or what have you, you're going to have some more questions. Maybe you want to do more, you're thinking more along the lines of Morse code. Maybe you're thinking more along the lines of soldering and putting circuits together. There's tons of kits, really cool kits that you can solder and build and so on. So we cover quite a bit of the scope of the hobby. This is just the very, very, very beginning. I've been at this now for over 30 years, and there's a lot of things. That's the reason why we have so many instructors here and so many Elmers, is because we all can't cover everything. And so all of us have our forte or expertness, or at least most expertness in certain areas. And so that's basically why we have so many instructors. So for those of you who are kind of like, okay, now what am I going to do? I can't figure this out. We work on motivation and the lifestyle, the ham radio lifestyle, which is it's easily incorporated into your normal lifestyle. But how do you do that? How do you incorporate ham radio into your regular lifestyle? So we can talk about that. Tricks and tips about the different radios and so on. So yeah, there's still a lot more to learn, and we're here to help you. So back over to John. This is Bob.
Okay, well, thanks everyone. And want you all to go sign up for your test, and we will talk to you on the air. Good night.
Good night, everyone.
Night. Everyone sign up, get your license.
Good night, and thank you guys. Thank you again. This has been a really good class. I really enjoyed it. So thank you.
Glad you enjoyed it, Michael.
Thank you.
Yeah.
Thank you all.
Thank you. Well, good night.
Take care, everybody.
Thank you.
Night, Bob.
Take care. Well, good night.
Thank
Roberta.
you.
Good
Night,
night,
Kathy.
Good night,
Thank you.
Karen.
Thank you all.
Good night,
Sleep
Ben.
well,
Good night,
Sheriff
David.
Bob.
Bye, Lisa. Good night, Lisa. Good night, George.
Thank you, Bob.
You're welcome.
Thank you, Bob.
See you next week.
Yes, indeed. You betcha. Take care,
Good to see
everybody.
everyone.
I'm headed off to bed.
Yeah, me too.
Yeah, you
Good
betcha.
night.
Good night.